coming out of this lab late, it's quite a bit of a work. So what Luis took basically all day to do was basically try to model the pasteurization, the temperature, which is given in degrees Fahrenheit, with the time it's taking to pasteurize, which the unit is in seconds. Well, he only got 2 data points, but we do know that it's modeled by an exponential function where the base is a integer and the exponent is a linear function. So now it's time to think about how we can model this function, as well as finding the maximum whole number of temperature, in which it would take more than an hour to model the entire thing. So let's get to business.
Okay, I sketched out a setup with a graph along with the general function form. Now it's time to figure out what the function could be. Well, it looks like 173, 1 is a good place to start. After all, anything to the 0th power is equal to 1, so we have 173a plus c equals 0, and so c equals negative 173a. Alright, one less variable to deal with. The other thing I can use is 161, 16. Now, by doing the substitution, I can get that b to the power of the quantity 161a minus 173a is equal to 16. Then I can simplify that to b to the power of negative 12a is equal to 16. Oh, and b to the power of a to the power of negative 12 is equal to 16 from those exponent properties, so b to the power of a is equal to 16 to the power of negative 1/12.
Well, looks like I ran out of data points I could use, but I wonder if that might be enough to actually model a function. Let's see if I can work with what I have here.
I now have t of d is equal to b to the power of ad minus 173a. Lots of variables. But wait, that's a times d minus 173. And there's that one exponent rule on power to power. So this means I can rewrite this as 16 to the power of the quantity 173 minus d, all that over 12. Alright, I think I have something, and at this point I can set up an inequality to finish things up. Now I need to first note that this is 3600 seconds since we're working with an hour. Now it's time to figure out when the output is greater than 3600. Well, I can put up an inequality and use logarithms, though gotta be careful with that sign thing when setting it up. Once I actually got the logs worked out, I could use linear equation strategies to get to the finish. Then I get that d is less than 173 minus 12 log base 16 of 3600.
Alright, at this point, I think I can just finish this off with a calculator and call it a day. But I think I know a way to do this without a calculator, this expression thing. So I'm going to go write that down and show you how to figure that out just for fun.
Now, log 16 is quite a lot to work with, but 16 is a power of 2, and I can then use change of base and other logarithm properties to work these into a more sizable and easier to work with numbers. Then I can have the quantity 173 minus 6 times log base 2 of 60. Alright, looks like I know that log base 2 of 60 has got to be between 5 and 6, but looks like that if I do those calculations, then it's just going to be between 137 and 143. Not tight enough of a bound. So I need a better bound than that. Well, I could think about a line connecting 32, 5 and 64, 6 when graphing log base 2 of x, because that line would lie below the log graph in that section. And then when considering sections, I can compare 58 and 2/3, which is 5/6 of the way from 32 to 64. And then when looking at the horizontal line and finding that 60 is greater than 58 and 2/3, I think I can observe something. In fact, I could estimate that log base 2 of 60 would be greater than 5 and 5/6, which means that the value is going to be between 137 and 138. That's just enough for me to say that the greatest possible temperature in degrees Fahrenheit that's an integer is 137 degrees Fahrenheit.
So write this down, that the max temperature in which it would take more than an hour to pasteurize a thing is 137 degrees Fahrenheit. Alright, got that lab done, so time to rest.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.